I think after the winter comes. Yeah.
Oh, wait, I sent you a picture.
Before I forget, the textbooks are in the media center now. This is what the new textbook fourth edition looks like. I looked through it. It's basically the same textbook problems as third edition, and third edition is what I've been using last year, and I've been photocopying the pages into your packet. So there's really no need for you to have a physical textbook in terms of, for this class. But the problems are pretty much the same. It's just in a different page. And so, it's just the new edition looks a little bit different, but the problems are virtually the same. And it just, I think the page, this a little bit thicker book. So I haven't looked exactly what's causing it to be longer. Maybe there's just more examples, there's more summary pages. But if you want a textbook, just know that if you're going to get a textbook, just leave it at home. There's really no need to bring it to school. I don't think you're going to need one, but if you want to have one, some students just feel like they want a physical textbook at home just for reference. So it's now available in the media center, but they just want to know how many textbooks to prepare so that if you guys pick it up sometime this week, they will have it ready for you. So you can always change your mind, but I just want to have a number that I can give them so they can have some idea. Raise your hand if you feel like you would like to have a physical textbook. You can always change your mind, but I just want to have a poll. Okay, thanks. And I will send out a reminder probably later today or tomorrow to say, hey, the textbooks are ready. Go and pick one up sometime between now and Friday. Okay, so they want that. Ideally, you can pick it up sometime this week. But let's say 2 weeks from now, you realize, wait, I do want a textbook, then just go to the media center and they will have one for you. All right, let's see. So you guys, does everyone have the test review that you guys picked up on Friday? So we're going to work through it. It says AB on this page, but I merged AB and BC together. It's basically the same. I just had a little bit more practice attached to this packet. So I just want to highlight what we're going to be kind of doing here. So between today and tomorrow, I'm just going to kind of work through as many of these problems. And if you guys can turn to page 25, these are going to be the test topics that you're going to be responsible for, and the test will be on Thursday. Okay, so let's just run through that real quick so you kind of have a big overview as to what you can expect. We need to be able to evaluate limits algebraically, whether it is a real number approaching infinity or one-side limit. We know that for real numbers, we always do direct substitution first. If it's approaching infinity, we always compare degrees. If it's a one-side limit, treat it like a real number. Do direct substitution. And only when you see infinity are you going to play with the decimals, right? So don't assume that every one-side limit is going to be decimal. It's only one-side limit paired with vertical asymptote. Evaluate limits with hole in the graph. So if the limit exists, but you're getting 0 over 0, then there are 3 methods that you need to be familiar with. Be able to know how to go through your factoring process. That will cancel out your holes. If there's radicals involved, and multiply numerator and denominator by the conjugate, that will also get the holes to show up and cancel out. And then you have complex fractions where you got to do common denominator.
Right, so these are the strategies if you get 0 over 0. Identify limits and order pairs from yeah. So if I give you a graph, be able to find limits, be able to find order pair, be able to sketch a graph given the limit properties. Continuity condition with piecewise function to determine continuity, discontinuity, categorize the types of discontinuity. We practice a little bit. We'll practice a bit more today and tomorrow. Apply intermediate value theorem to guarantee a y value. Horizontal asymptotes, radicals, and denominator. We know that these are a little bit different, right? That the degrees match, but we have two horizontal asymptotes. This one will produce what? What are the two horizontal asymptotes? Y equals what? What's one vertical asymptote for, sorry, horizontal asymptote for this example? Degrees are the same, right? So y equals 3 over root 5, but there's also, that's kind of like one of those staggered asymptotes here. So -3 over root 5. So we have two horizontal asymptotes, depending on which direction we're headed in. And these are like the strange exception. And then also comparative growth rates, right? You have logs followed by radicals, followed by algebraic polynomial, followed by exponential. And if we can only create this or follow this relationship if we're approaching infinity. And for this case, let's just do an example real quick. E to the 2x over square root of 2x plus 1000. Numerator falls into the category of e to the 2x is what? Exponential divided by radical. Which one is growing faster? Which side is growing faster? Exponential. Therefore, this is either going to head towards positive or negative infinity. And then how do we decide between these two options? Plug in a large positive number, right? 100 or 200, whatever. Either way, if I plug in 100, numerator, I get positive. Denominator, I get positive. So my conclusion is positive infinity. So this is the BC Calc test review that I created for BC students. So this is on page. Oh wait, did I put a page number? Okay, so I don't think I put a page number, but it's the very, very back of your packet here. So everyone see this here. So this is the BC test review. There's 4 pages to this. Pretty I think it's pretty good indication of what your test will look like. And then there's also a key attached. But I'm not going to go over this. I'm going to save this until Wednesday. Sorry. I'm gonna go over. I'm gonna start a new unit on Wednesday, but I'm pushing the test to Thursday. So I'm gonna save this to Thursday morning. So I'm gonna have a help session Thursday morning. You can either wait to go through this with me Thursday morning, or wait until Wednesday, right? Wednesday, when you're studying for the test, let this be your mock test, and then you can take it. And if you take it without looking at the key, and then you check your key and you're good, you should feel really confident going to Thursday. So I would, I mean, if you want to work through it earlier, I think that's fine. But I think do everything else and then treat this like a mock test, and that way, that will be a way to kind of gauge how ready you are Wednesday night going to Thursday. Yeah. No calculator. Yeah. Yes.
It's on the review, but I want to make sure. Is there going to be like sine and cosine as well as like natural log on the test?
Let me check. I don't think there is. Let me double check, and I'll get back to you. I'll let you know there's sine and cosine. I don't think there's going to be any. Or if there's any, it's just going to be a direct substitution and then using unit circle value to get to the numeric value. Yeah. Okay. Any other questions before we go back to the beginning of the packet? Okay. Do we get to number 3? We didn't. Okay, all right, so let's do that. It says find the value k that makes the function continuous. We see the word continuous, so let's just use continuity condition as a framework for us to kind of work through, right? If we can walk through continuity conditions, you're going to be able to solve for k without even trying to solve for k. Right? Go ahead and try that. I will work through it at the same time you guys work through it, and then we'll see if we line up. Order pair is unknown to begin with. We know the y value is some k. Second statement, we can rely on just one limit statement because there is no split of different functions on either side of -3. Both sides of -3 are sharing the same piecewise. So you can do one side limit, but you're just doing the same problem if you did that. So I just did the limit of my connected piece part of graph. Always do direct substitution first. I'm getting 0/0. That indicates there's a hole, but the limit exists. I found the hole by factoring, remove the hole, reevaluate it. I got -5. So my limit is -5. My order pair is -3 comma k. We want continuity, so we want all three conditions to pass. So my third condition, I just need my first and second condition to be equivalent, which means that my order pair and my limit has to be one and the same, which means that k must be equal to -1. All right, questions? Okay, next page. Page 2, I have these problems on kind of half sheets here. So if you feel like you don't have enough room, feel free to put this on a separate notebook page, or I have scratch sheets on my shelves there. So if you at any time you feel like you want to grab a scratch sheet, if you're not getting, you want to have more room to work, feel free to grab one. Yeah, so let's try 1, 2, 1, 2, and 3 on page 2. So these are good examples of the three categories of where we have to evaluate indeterminate form, but let's not assume anything, right? Let's always, I'm looking for you to check direct substitution. So when you're taking your test, even if your steps are even if you're getting to the right conclusion, I'm looking for direct substitution. I need to see that that there's a confirmation that there's a hole before you move into your other steps. College Board will also grade that way as well. They want to see the direct substitution step before you jump into all the other algebraic things that could happen. Number one, just be careful that when you factor your numerator, that you do need to do a little bit of cleanup with that denominator as well. That 2 minus x and x minus 2 are not quite exactly the same. So we got to factor a -1 from either the top or numerator, because there's a -1 that will be left over, and that will cause your limit to not be 5, but -5. I encourage you guys to use arrows as you are stepping through your problem, especially when you do direct substitution. College Board, they want to see an arrow. Well, they don't want to see an equal sign. So the way you can show that process without losing points is with arrows. As far as the limit notation, here's the general rule in terms of, when do we need to keep writing that limit statement and when can we drop it? So here's the general rule of thumb. As long as there's still variables in your expression, you're going to need that limit statement. But as soon as you do direct substitution at the very end of the problem, and once you get down to your limit where the variables have been replaced, then there's no need for a limit statement. So limit statements for variables, no limit statements needed if your value has, once you get down to your limit where the variables have been replaced, there's no need for us to hold on to those limit statements. Let's skip to page 5. Let's try another piecewise function where we have to decide which expression we're looking at and also what category are we looking at. Are we looking at approaching infinity? Do we compare degrees? Do we realize that it's a vertical asymptote where we got to play with decimals? right, let's touch base here. Page 5, A through D. Depending on where we are in our graph, that's going to decide for us which piecewise function to choose. We're approaching negative infinity, so we want to choose a value that is as far left as we can go. So that's x is less than 2. And we see we're approaching our negative or positive infinity here. We don't do direct substitution, right? We compare degrees. Degrees are the same. So I should take the ratio of the coefficients. Part B, approaching 2 from the left. That's slightly less than 2, but that is still referring to the same expression. But this is direct substitution. So we plug 2 in, we get 7 over 0, and we realize this is not a real number. We can't stop there. It is not 0 over 0, which means that there is not a hole. The limit does not exist. This 7 over 0, this indicates to us that there's a vertical asymptote. Normally, the limit does not exist, but then we go back and realize this is only asking for the behavior of the graph as we approach 2 from the left side of 2. So this is a decimal problem, right? So now we play with decimals, choose a value to the left of 2. Decimal 1.9, that should be close enough for us to get a good read on our graph. 1.9 plus 5 is positive. 2 times 1.9, that's slightly less than 4. 3 point something minus 4 is negative. Positive or negative is negative infinity. Part C, approaching 2 from the right. We're talking about the piecewise function that's slightly to the right side of 2, which is 2x minus 5. We do direct substitution first. This time we do get a real number, so we stop. There's nothing more to do with that. Part D, limit as x approaches 2. So in order for a limit to exist, first off, we see that we don't want to look at this 20, right? This is an order pair. This order pair does not, sorry, this 12 here is an order pair, is not helping us find the limit. We see that we have 2 different graphs, 2 different expressions split on either side of 2. We need to find the one-sided limit on both sides of 2, but parts B and C already did some of that work for us. We just have to compare. These are not the same. Therefore, limit does not exist since the one-sided limits are not in agreement. Okay, questions so far? Keep going. Hey, if you can get through this problem, you should feel pretty good because you know the distinction between real number, um, comparing degrees with infinity, and uh, when the vertical asymptote is guiding you to having to do decimals, right? That we don't do decimals as soon as we see one side limit. We want to go through direct substitution, go through our path that we've highlighted, and then we only play with decimals in certain situations, right? There's a vertical asymptote indicated with along with a decimal with the one side limit. Yes, question. Oh, for which one? F, yes, sorry. Let me double check. Negative over a negative. Let's see. What will I do here? Sorry, 5 minus 5.1. Thanks. Okay, thank you. All right, are we okay? Let's look at number two. Number two, use continuity conditions to determine if continuous or not continuous. If not continuous, identify the type of discontinuity. So uh, let's see if we can practice writing out our full continuity conditions. So this problem, can we rely on one limit statement or do we need two? We need two, right? We have different graphs split on either side of 3. We have two different expressions. Okay, so this is the way that I want you to be able to justify that the limit does not exist. We can obviously tell that 8 doesn't equal 23, no limit doesn't exist, but you're going to say limit doesn't exist because or since the one side limits are not in agreement. Make sure you write it out in this form. Even though you're saying, if you say 8 doesn't equal to 23, I know what you mean, but we want to be able to represent our justification in a more formal way. So this is the way we want to write it. Therefore, what type of discontinuity? Unremovable. Make sure we specify the location is not non-removable discontinuity everywhere. It's just at one point. see if we can get through the rest of this page. Number 5, there is a mention of continuity within our answer choices. I'm just going to just step through continuity condition, and it should be clear which of the options we're working with here. Everybody okay up to 4? Make sure you're writing out the statement like this. It's not saying 6 equal to 6. I know what you mean, but this is how we want to represent our third condition. Okay, so tonight's homework, you guys are going to finish the last part of the AP review practice or AP practice problems in your from your previous packet. Tomorrow we'll sketch graphs. Tomorrow we'll do intermediate valley theorem, maybe practice a squeeze theorem as well, and then continue going through our packet. But tomorrow will be the last day I go through unit 1 in class, because Wednesday I want to start the next unit and then test Thursday, but at least you have Wednesday to have an extra day for review. All right, come get your phones.
This first way.
Go ahead.
You said that the one side of the business right now. That's the ground is down there. And sometimes the conversation is very it's gonna happen. But or final question, we just do a limit as exposition.
I need my 40 minutes.
Yeah, well, you don't set that in.
Yeah, I'm well aware of it.
With one, I staff hours. I open to use it. I just don't know when to use it.
Yeah.
That's the question. Why would football here? Yeah. Yeah, that. What's your question? Like, I hate like. Because.
Like acid by the group.
You get like a board. Yeah. But you say, yeah, because I do the and then.
Oh, right.
Yeah, it should be in your packet.
Oh, is it just the AP practice?
Yes, that's it. Yeah.
Okay, yeah, cool.
I asked the teacher of it.
So because you're dealing with.
Boy.
You're the worst kind of person.
The worst kind of first place.
Yeah.
But you can't, you are, you know. So, physics usually don't be plus or minus. So I never. No. So, it's assigned to you. Yeah, okay. I thought.